can be produced, and from that graph you can calculate the mass. So, this is related to figure 3.13. So, if you have the book again, please look at figure 3.13. So, in this figure 1.13 you can see the schematic diagram of a mass spectrograph in which you have an ion beam, and whereby you can see how it is producing a beam with a distribution of different velocities because of the velocity selector, and then these ions are deflected, and the deflection depends upon the momentum within a magnetic field. You can see the crosses, these represent the magnetic field. You know, the typical symbol for a magnetic field, you have the cross and the dot. So, you normally take the cross to be into the plane of the paper, and you take the dot to be out of the plane of the paper. So, this is a representation of how, you know, ions are charged particles, right. So, they can be deflected with the help of a magnetic field, and then you can, with the help of the deflection, you can distinguish between the masses from the graph that you obtain, right. So, what other term do we have here? We have ion source. You understand what an ion source is? It's the source from which you are getting your ions, right. These can be atoms or these can be molecules, right. And normally a material is vaporized or it is bombarded with electrons and you produce ions. So, these ions can be formed as a result of different techniques like spark discharge or something like that. Then we have to select the velocities, and for selecting the velocity we have an arrangement which is known as the velocity selector. So, velocity selection can be done with the help of electric and magnetic fields. So, the electric field will be E and the force will be QE. Okay. And the field, the magnetic field in this case is B. Okay. Okay. And the magnetic field, the electric field will exert a force which is QE, the magnetic field will exert a force which is QVB, right. So, this force will depend upon the velocity and on the charge. So, if we equate these, we will get QE is equal to QVB, and therefore, we can find the velocity which is E over B. So, this is equation 3.19 in your book. Okay. Now, there is another term here which is the momentum selector. We had the velocity selector, we also have the momentum selector. Momentum selector is again a magnetic field that bends the beam, and this depends upon the momentum of the particles, and the radius of this deflection is given by r. So, in this case, if you are talking about momentum, we will have mv is equal to qb and r. So, in this case you can find the radius is equal to mv over qb. So, this is 3.20. So, qb and v are known. So, some quantities will be known and then you can find the unknown quantity, and therefore, so we can get the mass. We were trying to find the mass from the beginning. So, we did this experiment in order to find the mass, and the mass comes out to be QBR divided by V. So, this is QBR over E over B, and therefore, so you can this is one method that you can use in order to find the mass of the nucleus and hence the particles. Another term that comes in this section of the chapter is the term calibrate. So, what do you understand by calibrate? Calibrate means You know, do you understand calibrate? Yes or no? Yes, good. Do you understand calibrate? You all understand calibrate. So, these are also sometimes small experiments that we do in the lab to calibrate an instrument. Calibrate an instrument means you first measure a known quantity. For example, if you have an unknown scale, right, so, and you have a known value, you first measure that and then you mark where on the scale you get that value, and then you can measure an unknown quantity and accordingly you can mark your scale. This process is called calibration. Okay. So, now I am talking about another method for finding these parameters, and for this purpose I am going to erase the board. Let us start from there, huh? ठीक है? Okay. Remind me to take the attendance also. Okay. So, now we are going to use a method of nuclear reactions. This is page number 62. I am talking about page number 62 from this book. Okay. So, in this case we will we have the Q value. We are talking about nuclear reactions. Q value, what is the Q value? You are familiar with Q value, है ना? Capital Q, not small q. नहीं, Q in case of a reaction is the energy balance of it's the energy balance of the reaction. In this case, energy balance of the reaction. Okay. So, you know that whenever there is a reaction, either energy is absorbed or it is released, and you balance this. This is one of the laws of a reaction, right. So, this can be determined from the mass difference, right. Okay. So, Q can be positive and Q can be negative, right. So, Q positive means kinetic energy of products is greater than the kinetic energy of the reactants. Okay. So, this reaction is then known as exothermic or exergic. You are familiar with this, right. So, exothermic means thermic comes from thermal energy, heat. So, most of the time the energy is released in the form of heat, but in some books they also write exergic from energy, whatever the energy kind is. Okay. So, Q negative, Q negative, this means that the total mass of the reactants, total mass or energy of the reactants is greater than that of the products. So, this is called endothermic or endoergic. Okay. Okay.